Okay, so today we're moving on to 10.1. If you're not here today, Chapter 10 only consists of two sections, 10.1 and 10.3, and then we're going to take a quiz. That quiz is April 25th. I will give you that date again at the end, but that will be our quiz on Chapter 10, then we'll move back to Chapter 8. So now that we've seen how to solve square root functions and how to simplify square roots, we're going to look at what their graphs look like, because we can graph these because these are functions. So what is a square root function? It's a function that contains a square root, obviously, as per the name, with the independent variable in the radicand. Remember, independent being your x, dependent being your y. The parent function for the family of square roots is f of x equals the square root of x. If you don't quite remember what a parent function is, remember it's that function that has no transformations applied to it. No stretches, no compressions, no translations moving it either left or right, horizontally, or up or down vertically. So without any transformations, the parent function is just f of x. It's just f of x equals square root of x. All right. So, the f of x is just function notation, meaning that if I plug a specific value into my function, like say 1, for example, what does my function yield? Well, it's just 1, right? Don't let function notation confuse you. We've gone over that in the past, so just keep that in mind that it is a function notation. Okay, the other thing that you really need to understand with radical functions, square root functions in particular, is the domain. Okay, because what do we not want inside the radical for square root? A negative, because we don't want to deal with the imaginary plane at this point. So we always know that our domain for inside our radical, for our square root, has to be what? Greater than or equal to 0. Okay, this has to be true. If that's not true, then we can't graph the square root function. We'll be in the imaginary plane. So as you can see, that's what they said. The domain of f is x is greater than or equal to 0. So when you plug in numbers for a t-chart, you can't start with a -2 and a -1 like we did in the past. You have to start with 0, and then 1, and then 2, etc. Okay? You have to have the positive numbers. Now, you don't have to go in that order. You can graph any set of positive numbers, but it's nice with your parent function to start at 0 so you know where it starts exactly. That also implies that our range has to be positive as well. So if I plug in a positive x value, I'm going to get a positive y value. So keep that in mind. Now, there are going to be different things applied to square roots that may change this slightly. So if, for example, I have an x plus 1, then I'm going to have to set x plus 1 greater than or equal to 0 and solve for x to find my new domain. Does that make sense? So whatever's on the inside, that's the trick. Whatever's on the inside of the square root, you set equal to 0, or not equal to 0, greater than or equal to 0, and then you solve for x. Now you may have to flip the sign in some cases, which can be a little bit tricky, but we've dealt with that before. We've dealt with inequalities before, right? Do you have any questions? For most of these graphs, all you're going to do is find your domain, and once you find your domain, you're just going to plug in values. That's not it. It's not any more complicated than that. Does that make sense? Okay. Describe the domain. So what do we set greater than or equal to 0? Yeah, x Einstein. Anything on the inside. So don't let the 3 trip you up. It's only on the inside, because I don't care what the outside is, right? I only care what the inside value is, because I don't want my x value to be anything less than 0. It can be equal to 0, but it cannot be less than it. So I just set that inside that has to be greater than or equal to 0, and then I just solve for the value of x. So when I solve for the value of x, I get x has to be greater than or equal to 5 in order for me to graph this radical function. So in other words, when I start to graph this on my t-chart, for example, since it has to be greater than or equal to 5, I can plot 5 and see what I get. I get 0. I can plot 6, 7, etc. and solve for my y. Does that make sense? Or my f of x in this case. So when I plug in 6, I get 6 minus 5, which is 1. 1 times 3 is 3. So that would be my next value. How many values do you have to plot? I don't know, 2, 3, 3. 3 or more. I would say 3 or more. 2 is probably not enough. Okay. All right. Any questions about the domain? There's really not much to it as long as you remember the properties of your inequalities. Okay. So describing the range. Range, remember, is up and down. It's the y, it's the vertical axis that we're discussing here. So I just copied this from the book because they did a pretty good job explaining it. Sometimes they do, sometimes they don't. Describe the range. Now, notice here, the minus 5 affects my domain. It's also a transformation. What do you think it does to all my values? You think it shifts it left or right? Right. It's always the opposite with x, right? So it's going to shift it right 5 units. This is going to shift my graph. What do you think? Up 3. The nice thing about graphs and transformations, even though they're kind of difficult, they're pretty much all the same for all the graphs, right? You have shrinks, stretches, that kind of thing. Like that is going to be either a compression or a stretch, right? And then on the inside here, it's going to move it to the right. And we'll look at all that tomorrow. I don't want to get into too much detail on that today, because I don't want to overwhelm you. So, describe the range of the function. They said use the domain to make a table of values. So, they set what was on the inside of the radical greater than or equal to 0 and made a table of values. And they plotted it. So when you plot this and you're actually graphing it, you're just plotting points. And you can see that it starts at 0, 3, because this takes your pairing function, moves it up 3, and then you just shoot that way, right? So it's 3 or more. So in other words, y is greater than or equal to 3. It's just taking concepts we already know and applying them to radicals. So it shouldn't be anything different. Too different, anyway. Notice that you need to draw a curve, a smooth curve, not a line. Alright? Sometimes I get that. It's a curve, like a little rocket ship. Any questions about describing the domain? Describing the range? And graphing. That's all we're going to do today. And then I'm going to give you time to do it. It's okay to have a question. Alright. Here we go. Notice that, again, greater than or equal to versus greater than. There's no reason why you should have a restriction here, so you don't have an open circle, because you can be 0, 3. That is on your graph, so make sure that you include that little line under here. Okay, so we're looking at some practicalities here. The tricky part with these graphing ones is you really want to check values that, again, are you're easily able to take the square root of. So I know, for example, that x has to be greater than or equal to -5. I could do -5, I get 0, -4. -4. -4 plus 5 is 1. Square root of 1 is 1, right? But then if I plug in -3, am I going to get a perfect square? 5 plus -3 is 2. Square root of 2 is a decimal, right? So I may not want to try -3. Try another number, so that you're dealing with perfect squares. Does that make sense? So you get nice, even numbers to graph. That's the only really challenging part about this. And that's just going to take some practice. Okay. Do you have any questions about these before I show the solutions? Do you want more time to work on them? What do you need? Anything? Do you have any questions about the first three? Do you have any questions about 4, 5, and 6 before I show you the solutions in those graphs? Do you think you understand how to make the t-charts? Okay. Find the domain first and then pick values that will give you nice, simple, perfect squares. Okay. Now the graphing part, everybody always skips the graphing part. I saw some of you just kind of sit there, so make sure that you understand how to graph these. There are particular things that you're going to be accountable for, just like always when graphing. And we're going to do a heavy graphing chapter in chapter 8, so you want to make sure that when you're graphing, you remember your arrowheads, just like last time. Okay, you remember your x and y axis. That you give me a clear scale. Okay. And here you can see, like on number 4, when they picked values that were easy to square root, they got those numbers. Now you don't have to pick every single value along that same curve, just 3 or 4. Also remember to describe the range. There were 2 parts to this question, graphing and describing the range. So here, y is greater than or equal to -4, so they just took that parent function and they subtracted 4. Again, notice what these transformations did. This moved it down. This moved it to the left. Okay, and then we're going to talk about compressions and stretches as well. So this was obviously a stretch. Okay. Questions? All right. Please make sure to take those graphs seriously and that you label everything. Week or so. So we're only, like I said, we're only covering 10.1 and 10.3 for chapter 10. Because of that, we're not going to put together a homework packet. I'm just going to collect these. So 10.1 is due on Friday. I'm giving you everything now. You'll have the skills today to do this first half, and I would suggest doing that because there's a lot of problems. 36 through 24. These we'll tackle tomorrow because these are much more complicated. If you have graph paper, you might want to bring some. I'll bring some graph paper as well tomorrow. And then you have the rest of the time to either get started on that or work on your not summary, because we're not done with 10.1 yet. But anything you need in terms of this class.